Hello, folks, and welcome to Rational Science, the only site on the internet that does physics right. Anyways, last time around we had a little sound glitch. I have no idea why or how, and all I can do is, try again. So if you can't hear me for any reason, I'm going to try to keep an eye on that comments section there. Usually I get so involved in my stuff that I concentrate on my lecture and forget to pay attention to the folks out there that put comments. Anyways, I had a rough week this week. My brother finally died, one of them, and he was operated on Saturday. He lost half a leg, his right leg. He was cut just above the knee, and he was also paralyzed half his body. And he finally died yesterday. And so, yeah, he did not survive. He did want to die. Before he went into the operating room, he said goodbye to his wife, and he didn't think he was coming out. So he already had that sixth sense that he was on his way out, and that's what he would choose to do anyways. He probably didn't want to live for the rest of his life, halfway paralyzed, not being able to speak, and with half a leg. And one of the things we take for granted life, more than life, we take for granted that the constancy of life, the fact that we see people around every day and we expect to see them the next day. And it doesn't occur always, or is not always present, that some people, do not follow us all the way, and they get left behind. In the old days, they used to see death a lot more often than we do these days, especially of kids. By the early 1800s, at least 50% of the children, this is a calculation they've done and they figured out, that 50% of the children would die before the age of 5. There was a high death rate. And we don't see that anymore, at least not those numbers today. Almost every kid is allowed to live. The doctors are there. They typically know a little more than the witch doctors of the past. Okay? And they have a lot more tools to keep children alive. Whether that's good or not, some people criticize. They say maybe everybody should not be saved. Okay, that's an opinion. But the fact is that we do save more children today. We are more immune to certain diseases, especially childhood diseases. And so, we live longer ages, 70, 80, whatever, 90. And because of that, we don't see death as often as we used to. Okay? So, when we do see death today, it's like something out of the ordinary. In the old days, it was routine to see people die. Keep that in mind. A different mental set that we had in those days. Okay, anyways, let me get on with the first with the extinction part, and then I'll move on to the lecture and then to questions. Okay. Yeah, thank you guys. I hope you can hear me. I hope my sound doesn't get cut off. Okay, here goes. Person asked a question. I'm just going to run this with the questions that people made. Okay. And fellow says, must all species find their end through an absolute extinction? Okay. Or do not many species find their end through changes and adaptation, meaning evolution, right? Why is a complete extinction the only possibility for the human species? Okay, now I didn't determine this, nor God or Mother Nature. I guess it's just the way it is, right? And separately, what do species deemed living fossils that have continued millions of years mean for your theory? Theory is of extinction. Okay, the fact that humans, I say, are about to disappear from the face of the earth. We probably don't have, I think we have less than 100 years for sure. That's my take on that. That's my number. I'm saying we don't have 100 years to go. And so this person says, you know, why does man have to come to an end? Well, it just is. It's not that there's a why, like, you know, it's written in the heavens. I guess the only way you can see that, or the only focus you can give to that, is that all species are scheduled to die. There is not a single species that lives forever. Okay? And, you know, even some people say, well, bacteria have lived quite a long time. There's some bacteria has been around for millions of years. I'm not sure the bacteria that were here maybe, say, 1 billion years ago are the same bacteria we have here today. I think the bacteria evolved, okay, and you know, there's all kinds of bacteria out there even today. But I think if the bacteria today saw the bacteria of 1 billion years ago, they would run the other way. They would say, I'm not going to have anything to do with that monster. Okay, so I don't think they're the same bacteria. And let me give you a for instance here. Here's the most common. They're known as Lazarus taxon, living fossils or species that supposedly live forever or have been rediscovered to live after there's been a long period in which they did not, or they're not found in the record. Okay, and they're the famous lungfish. Okay, these lungfish, you'll see the African, the South American, and the Australian lungfish. Those are around today. And then you see at the bottom there, bottom right, the Devonian lungfish, and that guy is like the Neanderthals compared to these guys. I think if these guys saw that fellow, they would run the other way also. You know, they'd be scared of him, because I don't think their genes or the genetic makeup is the same. I don't think these species could mate with each other. Okay, and so, you know, lungfish is not a lungfish is not a lungfish. There are lungfish and there are lungfish. And I'm saying the lungfish of millions of years ago have nothing to do with the lungfish of today. And in fact, there are a couple of articles, more than a couple really, that talk about that. If you look up lungfish and look up the articles, you'll find that they've already essentially determined that, you know, the specialists, that those lungfish of, you know, the Devonian, you know, you're talking about at least 300, 400 million years ago. Those are not the same lungfish that you'll see today. They've occupied the same niche. They've, you know, they have the same general structure. They have the same function in the oceans, but they're not the same fellows. And, you know, the same thing will go for the sharks. You know, people say, oh, the sharks have been living around like 300 million years. No, it's not the same sharks. Believe me, after 300 million years, there should have been a gradual, right, at least, evolution of those sharks. Now you might say, well, it looks like a shark to me. Well, yeah, if you ask the shark or the lungfish, they'll say that we're monkeys, and they can't see any difference between a gorilla and a human. You know, you all have 4 legs, you're standing up, you know, and so on. One lacks a tail, the other one has one, so you're all monkeys. Well, that's more or less what we do when we compare lungfish of old and lungfish of today. So that no animal lives, no species lives forever, and some live more than others. And again, one of the questions is, you know, people say, well, look, the T-Rexes, they live like 2 million years, and here we are. We've been around, what, 200,000, 300,000 years, maybe. That's as far as we can trace our lineage today. And the issue there is that, you know, some species don't last as long as others. In fact, in our case, we were able to conquer diseases a lot more faster than some of these other species out there. So we were able to not only conquer diseases and modify our genetic makeup in a much faster time frame, and that distinguishes us from these other animals, which were really a lot more backward, and it took a longer time for them to do the same thing. And they did it by trial and error and sifting of diseases over a lengthy period of time, millions of years. It takes that long a time to build a species as big and as probably as immune to diseases as a T-Rex or a Triceratops was towards the end of the Cretaceous. Okay? And so here, let me show you something else. And this is known as convergent evolution, which again has to do with not being the same species. Here you have two species of plants that have essentially adapted the same architecture. They look more or less the same, and they're two different types of plants, but they converge upon the same niche and the same architecture. It's called convergent evolution, and one has nothing to do with the other. Okay, so they're not parents or related, at least not in the short term. Maybe if you take millions of years ago, they probably were, but not today. And so you got to think about that. The fact that you get animals such as the lungfish today, those are convergent evolutions. They're not the same animal, the same lungfish that existed, in the Devonian. Okay, another fellow raises another topic. He says, patriarchy isn't primitive. Instead, it's the only thing that works. Feminism is just more communism and doesn't work. Insufficient birth rate. But I wouldn't expect a communist to get it. Patriarchy wasn't just the Stone Age. It was every successful society. Well, what I put there underneath there, the family types through the ages. Again, this is a general picture, okay? And what you'll find there is that you have group marriages existed in the days of the hunter-gathering societies. They probably had matriarchy. That's quite a bit of speculation, but it says that since everybody had sex with everybody inside the cave or wherever out there in the savage world, no one knew who their father was, but everyone knew who their mother was. And the mother certainly knew their kids, but the fathers didn't know whether they were the ones. Okay, and so families apparently originally, came out of this matriarchy society in the sense that the kids belonged to the mother. Okay. And it was also a clan structure. Maybe the males had more power, or because they went out probably for the hunt and the women stayed behind and they had this division of labor. That's very possible. Again, a lot of this is just theory, speculation. You believe in whichever one you think is right for you. But at some point we went into this syndesmic family, and maybe that also occurred in the way past, also in the savagery age. And that's that someone would kidnap a woman, okay, maybe with the help of a couple other fellows, and they would all take turns, and then she would become like the bride of that group, so to speak. And so that is said to be also one of the possibilities that happened in the past. And they get this out of studying societies in the 19th century. That's where they got some of these ideas. At some point, we invented patriarchy, and that was where the male had, essentially control over the whole extended family, specifically over the slaves, and the wife was simply the number one slave, essentially. She was the head of the slaves. From there, we moved on to the age really starting in manufacturing, where we went into monogamous and the nuclear type of marriage, okay, mom and pop and the kids. And yes, there was some patriarchy even to this day in some societies, but patriarchy is really a type of society or a type of marriage that really existed in the past. So no, this fellow is wrong. Maybe it's not the Stone Age, but it certainly was in the age of farming, in the age of slavery. That's where we had patriarchy. That type of family died off over the years. We replaced it with the nuclear, or you could say monogamous family, even though it wasn't very monogamous. People cheated, okay? And today we have a different type of world in which we're moving into the bachelor society. Today people don't get married. They have sex, casual sex, maybe kids, maybe one or two. That's about it. And then they separate. Each one goes his own way, and then they get new partners and so on down the line. There's no group sex in the sense where they all live in the cave or in the apartment, you could say, and live forever in there, and the men go out and do the hunting, that sort of thing. Now that's old-fashioned. It's out of fashion. No, it's today we're headed into a bachelor society, an individualistic society, and that also has to do a lot with the service economy, which does not encourage in the cities to have large families. So the large family is what's dying, the extended family, and I think that's how man will end, with this bachelor society. So yeah, patriarchy I think belongs to the past. Doesn't mean that there aren't patriarchies out there. Obviously there are. Here and there you'll find pockets throughout the earth in different societies, especially backward societies. But the life in the city, take any city in the world, and I don't think you'll find much patriarchy at all. Very little, if anything. Okay, another fellow talks about race. Okay, says, I think a lot of us kind of have to pick and choose what we like about these ideas. Yeah, some of these are radical ideas, I granted, but again, the point here is to make you think, not to make you believe. You believe in whatever you want, but the issue is to try to get you to think and to see things from a different perspective. Okay, and so Bill is stuck in the neoliberal age where we don't know what race is. Well, I do address that issue in my Neanderthal book. We have race and we have species. The reason I raise that issue is because we need to know whether Neanderthals were the same species as we are. And the way I define species is interbreeding. In other words, do we have the ability to produce viable offspring with the Neanderthals? If we separated too far apart genetically, okay, then we probably would not be able to have viable children, even hybrids. Any hybrid that came out of there would probably be sterile, okay, for example. And so the question there is, did we separate sufficiently from the Neanderthals? And one factor obviously is time, assuming we had a common ancestor, as is speculated today, maybe 500, 600,000 years ago, right? That's the first issue. And then the second issue is whether, here you have the Neanderthals, he's born in Arctic weather. He's born in Northern Europe, and this is his hunting ground. This is where he lives. We, at least the assumption I make is based on the theory that humans came out of Africa. Okay, so I like that one for now until I find a better mousetrap again. Everyone chooses his own assumptions. My assumption is humans came out of Africa. Humans are nude. Neanderthals are nude. But Neanderthals are in an environment, cold environment, which they can withstand. Humans are the invaders. They go into Europe and know they cannot withstand the cold, so they invent clothes. I think that's why we invented clothes primarily, to be able to withstand the cold. And so here you have these two animals, assuming they met, which is still yet to be proven, okay? Assuming they met, one is clothed, the other one looks like a gorilla, okay? Essentially, he's got his fur, okay? And so the question is, this hairy animal and this human which is dressed up, I think they would recognize each other as different species immediately. Okay, by the smell. Maybe they mark their territory, like raise their legs to say, don't mess around here, this is my hunting ground. They probably had all these signals out there. Surely they couldn't speak the same language. And so I don't think they made it at all. And so, but even if they did, the question is, with this lengthy separation in two radically different environments, could these two animals mate and have viable offspring? My answer is no. They were different species. Different species. Species meaning they cannot have viable offspring if they interbreed. Okay? And so, starting from that point of view, we know what a species is. Now, what is race? Well, race is really a cosmetic issue. It's more a political issue than a scientific issue in that sense. You can ask the scientific question, why is there a man that's black, another one that's white, another one that's yellow, another one that's brown? You can ask all that and search for an answer to that question, to that kind of question. That would be a scientific issue. But other than that, it's more a political issue, because that's what this guy is insinuating. You say, well, I don't like blacks, or I don't like yellows, or I don't like whites, maybe he's black, So it's like, that's his point of view. And that doesn't enter the picture in science. Those are cosmetic differences, and we are territorialists. And so here you have the white man, and he conquers For example, in the United States, you had the white man come over and he kicked the Indian out, the American Indian. And they could each recognize each other, not only by their outward appearance, but their culture, many things involved there. So language, so they could recognize each other as different. And different means enemy. We stick together here and they stick together over there. We have to fight them. And whoever wins, well, that guy wins. Sorry, that's life. And then the white man brought the black man, dragged him over to the Americas, and now there's also, hey, that's the enemy, and we're the whites, and they're the blacks, and so on, and that's all political, So those are issues that don't enter the picture in science. The only part again is why did some humans end up being black, others white, others yellow, and others brown, or whatever color. Maybe some green ones out there. And so that's a scientific question. Now, as far as the genetics, people will be surprised, but we're not. There are no races as far as genetics are concerned. We are all essentially the same. You take a black man from Africa, you take a yellow man somewhere in Asia, you take a white man from Europe or Russia or the United States, and you bring them together and they have the same genetic code, essentially. They are brothers and sisters. And, we can mate with that person because you say, well, he's a different race. Yeah, but you can mate and have viable offspring. And so we're the same species. We have these cosmetic differences, pigmentation, whatever. And, that doesn't prevent us from mating, having viable offspring. So we're the same race, same species. Race is more cosmetic in that sense. There are no genetic differences between the so-called races. Okay, and that's the point you got to emphasize when you talk about race. Okay, next issue here. Fellow says, if you think that farmers will be able to defend their crops, take a look at the South African farm attacks. Obviously, the attacks aren't motivated by food, but by racial hatred. But the point remains, that would be our future. Yeah, this fellow says that, you had this, the blacks rise up once they got a little more power and they were a little jealous, or they wanted revenge against the white settlers who had conquered them 100 years earlier, and here were their offspring. They were the owners, and still are the owners, as far as I know, of many of the farms in South Africa and that whole region in Southern Africa. And so, a lot of the blacks say, well, we want some of that land back because that belonged to, I don't know, the Zulus or whatever. And so what are you going to do? I mean, it's like the Israelites today, they want their land back. They say it was stolen from them since biblical times. And so now they have the power in their, overcoming the Palestinian people, and so there's this war because of ideals, because these people say that land was ours and now we're taking it back now that we have the power, that sort of thing. And that happens and has happened throughout the world in different places, on and off constantly. It's like if the Incas today of Peru wanted their land back from the white settlers, the white Spaniards who took it from them, and they go and say, hey, white man from Lima, we want our land back. So, because you stole it from our great grandfathers, politics again. But this was the issue. The issue is that another guy answers, says, make no mistake, even the Amish own guns. This isn't South Africa. And again, all I can say is the Amish own guns to hunt rabbits, okay? Not to hunt people. Amish don't kill people under any circumstances. It's against their religion. So to say that these people are going to, if you kill one of theirs, one of their own there, in the Amish camp, they're not only going to pull their guns out and say, and create a posse and come after you. No way. Okay, in fact, it's happened where there was a crazy guy went into one of these schools and killed several girls in the Amish town. And what the Amish did was pray for him. And that was their answer. Okay, they prayed for his soul. So, you know, you got to think about all these things. The Amish don't go killing people. It's against their religion. It's against their way of thinking. They wouldn't do that under any circumstances because, again, they have this invisible thing that holds them back. Okay? And it's their beliefs. Okay? They're not violent people. Neither are the Mennonites, by the way. Okay, another issue. Fellow says, speaking of amputees, referring to my brother, okay, why does God hate them? Okay, I like that. The Bible and other religious traditions often refer to medical miracles performed by Jesus or other figures. Yeah, okay. The blind can see, the crippled can walk. Usually it's the other way around. They say that the deaf can see and the blind can hear. You know, that's more or less the miracles that Jesus used to perform. And seemingly fatal disease can be cured. Okay, you see it in nature. A starfish or a salamander can lose a limb and have it regenerate. Okay. But God won't perform this miracle for human amputees, and it seems to me it could only be because he hates them. Hates the amputees, or man, I don't know which one he's referring to, but fellow's got a problem in reasoning. I mean, first of all, you know, lions don't grow their legs when one is chopped off. Neither do hyenas. I don't think that eagles grow their wing if you cut one of them off. There's so many animals that do not grow their limbs back if you cut that limb off. Hopefully God doesn't hate all of his creation. Okay, that's the first one I want to mention, okay? But here's a little education for him. I'm going to define the word Christian. What is a Christian? Okay, let's find out what a Christian is. Okay, this is a scientific definition of Christian. Okay, you heard it here first. Here it goes. Okay, Christian, it's a person who never read the Bible. Okay, so here's poor old God, and he's typing his manuscript. It's going to become the Bible. And it's a bestseller, but nobody reads it. So it's the bestseller and the worst reader, you could say, okay? Nobody reads the Bible, and if they don't read the Bible, you can say, well, he's a Christian. That's why he's a Christian still, okay? And but let's read it for a second. Let's look at some passages where God really tells us what he thinks of us from the Bible, okay? This is strictly from the Bible. God says, and there was not a man to till the ground. He had made all these animals, everything. He didn't make by any chances, he didn't make anyone to work in the garden. So the Lord God formed man out of the dust of the ground and breathed into his nostrils the breath of life, and man became a living soul. I think, you know, we'd like to know what the process is, how God turned clay or whatever from the ground into carbon, because, you know, we don't have... Our bodies are not made of silicon. Our bodies are made of carbon. So how we turn silicon to the carbon is the miracle we'd like to know. Okay, he says he just did it by breathing on them. That's quite a magic trick. Anyways, and the Lord God planted a garden eastward in Eden, and there he put man whom he formed. Okay, so now he's got a gardener. Okay, and so he says, so God created man in his own image. In the image of God created he him. Okay, so obviously man looks like God, God looks like us in general terms, right? Maybe with a beard, maybe without a beard, but essentially he looks like us. And then he continues, male and female created he them. So I don't know if God is a female. It doesn't look like it. It looks like God is macho, okay? And that's not surprising because, you know, we dominated women. In fact, if you look at history, that was essentially the first class distinction between men and women. Then we went between men and men, but originally I think it was between men and women. If you read Engels' book, The Origin of the Family, Private Property in the State, you'll read it there quite well. Anyways, what Engels said is that, yeah, first there was a division between women and men, and where men started dominating women, primarily I think because of war. Men were more qualified to do war, and women stayed behind and became widows. Okay, and from there, you know, men thought they had the right to rule over women, and that's what's happened for most of our civilized history. What happened before that is more theory and speculation, but I think we can safely say that once we started civilization, meaning war, conquest, stealing, that's called civilized. That's when we conquered women, and then we conquered slaves, and so on down the line. Okay? But yeah, we had this division, and women were left behind. But the issue here is that this history that we've had, where we relegated women, is something I think we could not have avoided. As I showed before, there was a transition from a patriarchal society or clan or whatever you want to call it to a society where we had this monogamous, supposedly, at least in nominally, okay, monogamous marriage, or you can call it nuclear family. And today we have the bachelor. And now that we have the bachelor, we have the women more or less come up to par again after thousands of years. And part of that is because they work in the same type of work. They do the same type of work that we do, that men do. And so there should be no reason for the distinction in the family, in the matrimony, if we can call it that, because again, a lot of people don't even get married today. So we have this evolution, and I don't think we can turn the clock back on that. Okay, races, again, not important scientifically, other than why we have different pigment colors. That one might be a topic to investigate. Okay, so let me finish with this. And again, one more thing, just God, again, if God created us, he created us in his own image. I think we're his favorite creature. So under no circumstances is it because God hates us or amputees. Again, most animals, especially most mammals, cannot grow their limbs back again. So that's faulty reasoning. Okay, I always put this up here that you got to do 101, Extinction 101 before trying to do 102, which means you first have to address mass extinction. You got to do a little research on that to make sure you're solid on mass extinction. You understand how mass extinctions really occurred. And when you read out there a lot of the papers, and I'm talking about scientific papers that are being published, you'll get a feel that these people have no clue whatsoever. They have no idea how mass or background extinctions ever happened. Okay? And so, yeah, all I can say is that's the case. We don't have a theory. I do have a theory, I think, that you can sink your teeth into. And by that I mean that at least it makes sense. I'm saying that if you remove food, we will die, no matter what. And so the only issue is whether you can understand, not believe, but understand that if we remove food from the planet, humans die. And the way we remove food from the planet is by killing money. If money is no more, food is no more, because no one has an incentive to produce it or distribute it. Very simple theory. And right now I have a lot of people who have no understanding, not belief, but understanding that without money we don't produce food. And that's where I'm stuck right now with so many people. They just can't wrap their brains around that idea that without money there is no food. The whole chain of pushing money in one direction and eventually getting that to produce food, they don't understand that. They don't understand that if we cut those chains, that whole system disintegrates completely. And then, once you get that, then if food is the cause, that the trigger that caused the mass extinctions in the past, if you extrapolate it to man, you can conclude that without money we have no food, and without food we certainly will die. It's not an if, it's a question of when. Okay, let's move on to the subject matter of today. See if I can get this up here. Give me a second here. Okay, and what we have is I've been reviewing geometry, last couple of weeks. And the issue here is that, we have no figures in geometry. There are no true, genuine figures in geometry. Why is that important for the subject of today? Because I'm going to be talking about black holes. And the question is whether the black hole is a geometric figure. You might say, well, Bill, where'd you get that? I mean, wasn't it a star that collapsed on itself, by gravity, gravitational collapse? Yeah, but what do you end up with? You end up with a point in the center of what is known as an event horizon, which is, like this volume or this region that surrounds that center, that point in the center. And so we need to know what a point is, because that's what a black hole is. It's a point. And you say, okay, what is a point? Well, we already covered that. Point is a location. It's not a geometric figure. Okay, it's a location. And for hundreds of years now, we've been fooled into thinking that we were looking at a geometric figure that is always represented with a dot. Could be typically it's a two-dimensional dot. Just you hit the pen against the paper and you're looking at it as a two-dimensional thing there, right? And some people say, well, it's got some relief, yeah. So you can say it's three-dimensional. But the point here is that when you have a little dot on a piece of paper or a chalk mark on the board, we think of that as a two-dimensional figure. Think of it as a circle, okay? But a circle is two-dimensional. And so the question is a dot two-dimensional? Well, a dot is a two-dimensional figure, but that's not what a point is. The point is this dot, this two-dimensional circle that represents what? A location. So the point is really a location, and that's what the geometer is going to work with. He's not going to work with a dot. He's not going to work with a circle. He's going to use those as pictorial representations of this abstraction known as location. Okay? And in mathematics, they call it position because they designate it, for example, with an ordered pair, the most common one, Cartesian coordinates. Could be triplet, etc. So what is a point? We're talking about a location of a location on something. So if you have a wall, if you have a ball, if you have a cube, whatever you have out there, the dot represents a location, a pictorial representation of a location on this cube, on this circle, on this wall, on whatever you put there. Okay, so that's how it works. And so it represents a location. But then the question is, if it's a location, why didn't the Greeks, who invented all this stuff for us or served it in a gold platter to us, why didn't they just call it a location? I mean, if what they're going to be using is a location, call it a location. Why call it a point and mislead you to believe that they're referring to a geometric figure such as a two-dimensional circle, a plane, and call that thing a zero-dimensional point when they really mean non-dimensional location. Okay, we see how this gets confusing, because then they'll tell you, well, we cannot define the point. Well, of course you can't define the point because you're using the dot of physics, which is an object, it's a figure, it's a two-dimensional figure on the one hand, but then you're trying to define it as a zero-dimensional what? What is a zero-dimensional whatever? You're talking about a concept. And what's the concept? Location. Okay? So we get to the issue where we get here, where we're going to build the line, the next geometric figure. We call it a one-dimensional line, and it looks more or less like this. It's just a string of locations. And what they're talking about is an itinerary. Okay, that's what it is. So you say, well, if these are the foundations of mathematics, okay, the question is, how rotten is geometry? It looks like you built your building on quicksand. Okay, because look at the foundations. The foundation is the dot, which is a location. It's represented by that ball or two-dimensional plane, circle, whatever. And then they put another two-dimensional figure, which is an elongated rectangle, very elongated rectangle. It's obviously two-dimensional. Both of them are, because you can see both of them. You can't see anything below 2 dimensions. And what is it? They're talking about locations. What is a 1D line made out of? One-dimensional line made of? 0-dimensional locations. What are they talking about? They're talking about one-dimensional something? No, they're talking about a series of locations. They're talking about an itinerary, a trajectory, maybe an orbit if it's curved. Okay, so that's what they're talking about. That's what a line is. That's how it's defined. But then they put a little stick and they say, see, that's the line. No, that's not the line, because they have no use in mathematics, in geometry. They have no use whatsoever for that stick or for that little ball. They have no use whatsoever. They're going to be doing math. They're going to be doing angles. They're going to be talking about parallel and perpendicular. So they have no use for these geometric, the figure itself. Okay? They have no use for figures in mathematics. And that's what geometry is today. It's just a bunch of relations that tries to unite mathematics with physics. In fact, it's the origin. Geometry is the origin of so-called mathematical physics. Mathematical physics is a contradiction in terms. It's an oxymoron, because you have math, which is a language. It's a language that can only describe. And you have physics. Physics deals with objects, and the purpose of physics is to explain what? Mechanisms. Never the twain shall meet. You cannot merge physics with math, math with physics. And this is the problem here, because geometry tries to merge math with physics. And you say, well, okay, we need to establish relations, we want to do measurements, we want to come up with calculations and equations. Yeah, fine. Leave that all within math. Don't bring it into physics. In physics, we have to explain how Mother Nature does her stuff out there. We need to know how she does gravity, how she does light, how she does atomic behavior, quantum jumping and that kind of thing, or magnetism and electricity. That's what physics is about. That's what we want. That's what the ordinary person out there wants to understand. He doesn't want to do math. He doesn't care about math. That's why physics has become so unpopular among people. Nobody cares about it, because all these people come in there with math and with abstract concepts, new concepts they invent every day with words this long, and people say, I don't want to deal with all that. You guys deal, you're the experts, you deal with all that. Just give us the bottom line. And the bottom line are the physical interpretations. And what are these people saying? They're saying nonsense. They're saying a particle can be at 2 places at once. They're saying there's a physical object called space-time out there. They're saying there was a big bang, an origin to matter. Even though they're atheists and they don't believe that there's a God that created the universe, they do believe that there was a moment of creation that matter came out of what? Out of nothing, or energy, or whatever they want to call it. So they have all these ridiculous, irrational explanations on the one hand, which they serve to the public, and the public believes them simply on the basis of authority, because nobody wants to deal with the math. And so, yeah, physics has become a very unpopular thing. Nobody does physics out there. Nobody cares about it. It's just the specialists who deal with physics, and they're all brainwashed in the same way at the universities. Otherwise, they don't get the degrees. They don't get an advisor. And what do they talk about? Well, they talk about the nonsense. Nonsense such as what? A black hole. Okay? That's the kind of nonsense they talk about, black holes. And yeah, people say, whoa, we took a picture of them. Well, I'll get to that in a second. Anyways, here's the famous circle. Okay, and again, that's an orbit. I talked about that in the past. Okay, here's the cube. Okay, and what is a cube? Is a cube a solid figure? No, it's a hollow. It's made out of all these points. Okay, so the question is whether that is a 3D object, or it's a bunch of locations. Are we talking about a perimeter? Is that what we're talking about? In which not even the ones in the center are there, because it's like they look at lines, and so it's like they have a cube made of lines that go from corner to corner, and it's essentially a cube is a 6-sided window, or 6 windows on each covering it. and it's got no window pane. There's no glass in it. Okay, so it's just the lines. And in this case, this is another version. It's just a bunch of points. So the question is that what a cube is? Because this is a hollow, not a cube, okay, and not a solid. Okay, so what is the problem with all this? The problem is that, again, they're going to extrapolate all these notions that they have in geometry. They're going to extrapolate them into general relativity. General relativity, what is it? It's a geometric theory of gravity. Geometric theory of gravity. I didn't say that. These people say it. I'm just repeating it. I'm just regurgitating what they already said. It's a geometric theory of gravity. They're going to explain gravity as being a geometry of space-time, the warping of space-time, the bending of space-time. What are they bending? They're bending time. They're warping time. Not facetiously or even figuratively. They're saying literally. They're warping time. Okay, so why doesn't the Earth fly out of the solar system? Because there's a warped wall of time that comes in contact with the skin of the planet. Okay, that's what's happening here. And because they have to explain why the Earth doesn't fly out of the solar system. And you say, oh, what prevents the Earth from flying out if it's swinging around the sun? And so, we say that every atom of the Earth is tied to every atom of the sun. We have a physical entity holding the Earth. Now we see why the Earth doesn't fly out of the sun. We have a mechanism that is valid. What is their mechanism? Their mechanism is not that the Earth is connected physically to the sun. Their mechanism is that there's a roulette kind of thing, and our Earth is a little ball that rolls around this roulette. So the skin of the Earth is coming in contact with space-time, with warped time. And so they're saying that warped time is what physically prevents the Earth from flying out of the solar system. That's their explanation. That's their physical interpretation. And of course, when you throw this in their face, they say, well, you're not supposed to take the analogy literally. That's their answer. You're not supposed to take the analogy literally. You got to take math, they say, to understand what we're saying. We want to know the physical interpretation. We don't care about your stupid math. That's the answer to you. We want to know the physical interpretation. What prevents a solid object such as the Earth, not solid completely, but I mean, it's quite solid, right? It's a rock. This roundish rock, rolls around the sun. What prevents this rock that we know is here because we put our feet on it, What prevents it from flying out of the solar system? What prevents it from flying out? And these people are saying warp time. And then when you put them against the wall and say, well, what do you mean warp time? It's a concept. They say, well, you're not supposed to take the analogy literally. You got to take math to understand. That's the answer. So yeah, we have irrational explanations, and what people want to know, if we can bring them back into physics, is the mechanism. That's what people want to understand. They don't want your equations. Okay. So what happens? It turns out that a black hole, is a, what is it? People are not aware that it's a zero-dimensional entity. Yeah, it's a zero-dimensional thing. And you say, what do you mean a zero-dimensional thing? Then let me show you here. These are comments that people make. Oh no, let me first start with this. I want to cover this first. So what does a mathematician do if he wants to give you a physical interpretation? Like I just said, why doesn't the Earth fly out of the solar system? Well, I'll give you an analogy. I like this analogy, that's why I don't want to skip over it. You see a hole in the wall. Okay, you see this, okay? This is what you see on the wall. And you call the expert of math and you say, okay, tell me how that hole was made. Hey, can you explain that? And the guy comes in there with his ruler, whatever he brings in there, his calculator, and he measures and he does all his experiments that he needs to do, and he calculates, he comes up with an equation, and he says, yeah, I can tell you exactly how that hole was made. Okay? And this is what he proposes. He proposes that it was made by a unicorn. That's what he tells you. Say a unicorn, but hold it, unicorns don't exist. What do you mean a unicorn? And the guy says, well, yeah, you're not supposed to take the analogy literally. What do you mean? I mean, you're giving me an explanation on how the hole was made. You're saying it's a unicorn. I'm telling you that unicorns don't exist. And your answer is, well, you're not supposed to take the analogy literally. That's the kind of answer you get from these people. And so here's a black hole, okay? Because they talk about them in these conferences. They talk about their equations, all that fancy stuff. And they even took a picture of it. And here's the picture of it. Isn't that fascinating? Look at that. Look at that picture. Beautiful picture. So what the hell are we staring at? Are we staring at a black hole, as they say? Actually not. What you're staring at is, according to them, okay, matter falling into a black hole. Remember, a black hole is zero-dimensional, and a lot of people have trouble with that. In fact, when I had my talk with Garipi, a fellow in Canada who has a show, I told him that that's what a black hole is. A black hole is zero-dimensional. And he said, well, no, that's not true. And so I showed him evidence, and he still did not believe me. You know, I didn't create the evidence. I was just putting out what the experts out there say. And he still refused to believe that a black hole is zero-dimensional. Because if you can show to anyone that a black hole is zero-dimensional, and they actually come to grips with that thought, with a notion that a black hole is zero-dimensional, it's just a location with nothing in it, it's just infinite density, because it's got all this mass in zero volume, so you got infinite density. And so what is a black hole? Well, if it's zero-dimensional, it's not much of anything. That's what it is. It's a point. It's a geometric point, which is what? A location. And this location is surrounded by what? An event horizon, which is the best way I like to explain an event horizon is that, you know, campfire. You put a campfire and the heat, you know, has a certain distance. After a while, if you move far enough, you won't feel it. You'll be cold. You'll be out in the cold still, right? It's like the heat doesn't reach you. But the closer you get to the campfire, well, you know, there's this radius in which there's still heat. And that's more or less what a black hole is. The region of influence of a black hole at the velocity of light in which it overcomes the escape velocity, as it's called, that reaches up to the event horizon. After that, you know, you're pretty much scot-free, you know. And so it's a zero-dimensional location, infinite density, that's surrounded by a region of influence of which the perimeter is called the event horizon. That's more or less what a black hole is. So far we have nothing in front of us. It's just abstractions, mathematical abstractions. That's all we have. We don't have a physical object. For example, we don't know why or how a black hole would be able to influence a star that is a few light years away. How would it move it around itself? By what physical means? That's the question. And you cannot use the word mass and say, well, it does it through mass or gravity. Those are concepts. We need to know what physical entity is in contact, physical contact with that star. And that's where we lack in understanding, because these people are not putting a physical object between the black hole, which is already not a physical object, and the star. We need to know what's connecting them physically. Is there a connection or not? And what they say is, you know, the black hole warps space-time, and again we get to this issue where they're warping time, and that's what's compelling the star to move around like a little ball around the roulette. That's the answer. So the first thing I want to establish is that a black hole is zero-dimensional. For those of you who have a little mental capacity to understand, a black hole is zero-dimensional. Is that what I say? No. I'm going to put evidence from the, you know, gurus, from the head honchos of general relativity. Okay? If you don't believe them, I don't know who you're going to believe that. You don't have to believe me. I'm just going to put their testimony so that you understand what these people are telling you. Hopefully you're opening your eyes, your ears, and listen to what these people are saying. Okay, here goes the first one. First testimony. We called to the witness stand Mr. Stephen Hawking. Okay, I hope you understand who he is, or remember who he is. He died a couple years ago. He wrote a book called A Brief History of Time. What is it? I think it's 87 or 78. It's 87. Okay, 1987. And he says the following, and this has to do with Chandrasekhar, who won the Nobel Prize for demonstrating that a black hole is zero-dimensional. He proved it mathematically. Okay, let me repeat that because some people haven't heard that yet. Chandrasekhar proved that a black hole is zero-dimensional. He proved it mathematically. Okay, we got that? And I'm just repeating what this man's going to say now. He says, Chandrasekhar calculated that a cold star of more than about 1.5 times the mass of the sun would not be able to support itself against its own gravity. 1.5 times the sun collapses to, it can't support itself against its own gravity. What does it mean? Would it collapse to infinite density? What is infinite density? It means no volume. That's what infinite density means. No volume. You can put as much mass as you got. It doesn't matter because if you have no volume, you've got infinite density. You're dividing by zero. Okay, that's essentially what it is. Eddington was shocked by that implication, and he refused to believe Chandrasekhar's result. Arthur Eddington was Chandrasekhar's supervisor, his boss. And he said, I'm not going to let you publish that nonsense. You're not going to ridicule the mathematical establishment. So he was dead set against that. And not only him, as we'll see, also Einstein, who was a big man by the time, right? Eddington thought it was simply not possible that a star could collapse to what? To a point. What was a point in geometry? A non-dimensional location. That's what a point is, okay? Einstein himself wrote a paper in which he claimed that stars would not shrink to zero size. What did Einstein say? That it was not possible for a star to shrink to zero size, no radius, no diameter, no circumference. I hope that's clear. I mean, people then say, no, they never said that. Here you have it. Everybody's talking about zero size, infinite density, etc. However, he was awarded the Nobel Prize, Chandrasekhar, in 1983 for his early work on the limiting mass of cold stars. Chandrasekhar had shown that the exclusion principle could not halt the collapse of a star more massive than the Chandrasekhar limit. He proved mathematically through an equation that a black hole is zero-dimensional. A star that is bigger than the sun, so many times bigger, it doesn't matter, collapses to zero size. I think it's clear. Okay, but some people say, well, that's poor old Hawking. He's not around anymore. He's got no authority. Okay, let's bring some more proof, evidence. Okay, people need authority to believe, so let's make them believe. This is a black hole. So you can see it's zero-dimensional. What does a black hole look like? Like that. It looks like zero-dimensional nothing. Okay, so here's another testimony. This fellow's name is Chaudhry, and he wrote a book and published it in Cambridge, at the Cambridge University Press. Okay, so he was a teacher, a professor for many years in different universities. Okay, so he's not a nobody. He's a somebody. Okay, not the biggest somebody, but certainly a guy who was specialist in this kind of subject matter in black holes. It says, on solving the equation with a particular value rho of central density, you will get a model of a star with mass m and radius r. Okay, plot r, radius, as a function of m, mass, right? And show that r falls to zero. Falls to zero when m is equal to the Chandrasekhar mass. If you can do all these, then you have repeated the calculation for which Chandrasekhar won the Nobel Prize. I hope you understood all of that. If you have 2 fingers worth of brain, okay, I'm sure you can understand that. They're talking about zero size. Okay, you still don't believe. We'll bring Mr. Harrison to the witness stand and we'll have him testify. He's a professor at Toronto University. Many years. He's prominent on the internet, and you can visit his site. His name is David Harrison. And it says, if the mass of a star is greater than about 3 solar masses, here we're talking about 3 solar, the other guy said 1.5, okay, fine. It goes through the neutron star stage and keeps collapsing. In this case, the gravitational attraction is so intense, the neutrons are literally, what? Crushed out of existence. Crushed out of existence. They turn into empty space, into nothing. That's what he meant. We call the object a black hole. I hope everybody understood. Straightforward. I characterize a black hole as an object whose gravitational pressure is so intense that the matter of the object, again, is crushed out of existence. And then he goes on to make a calculation for the Earth and saying, well, this is, if we could crush the Earth to such and such size, then we would get a black hole. And again, he says, you know, the issue is that if it's got enough mass, it can continue to collapse until there is no matter in there. There is no structure. There is no nothing. There's no matter. And the issue there is, again, that people in high school get educated to repeat verbatim, you know, that mass is the quantity of matter or a measure of the quantity of matter. It turns out that a black hole has no matter whatsoever. And yet it has mass. It's got infinite mass almost, you know, it's got all the mass you want to put in there, whatever the star had at the beginning, whatever it collected. So it's got more than 0 mass, but it's got 0 matter. And so if mass is a measure of the quantity of matter, a black hole should have 0 mass. And yet here they talk about all this mass that moves stars around, that sucks their skin, their gaseous skin into the black hole, which is the picture that you saw a minute ago. And they say all this happens because of mass, but a black hole has no matter because all of it has been crushed out of existence. You figure it out. See if it makes any sense to you. Okay, are we going to stop there? Now we have a little more informal, but still popular version here. This is from space.com, and that one comes usually from writers who essentially translate some of the papers that the mathematicians write that are unintelligible for the public. And so these guys kind of translate it and bring it down to the level of the human mind, the normal human mind. Okay, and so here's what the space.com said. This is in 2004. As to what lies in the region between a singularity, what is a singularity? A location in the center of an event horizon, which is a spherical region that covers the center that's in that's in this volume. Okay, between a singularity and its event horizon, physicists have always drawn a blank. Yeah, more or less a blank, like what is there? That's a blank too. Okay, there's nothing there. Physicists have always drawn a blank, literally. Yeah. No matter what type of material formed the singularity originally, right? The area inside the event horizon, or the volume, right, was supposed to be devoid of any structure or measurable characteristics. There is nothing inside a black hole. A black hole is 0-dimensional, no matter whatsoever. There is nothing there so far, according to physics. Okay? I don't care what the mathematicians say. There's nothing inside a black hole, and a black hole is made of nothing. Literally. Blank. Just like this guy said. Okay, so here's the $1 million question for you to ponder. Okay, $1 million question. Is a black hole 0D? If it is, then does it qualify as a figure? Because if it's 0-dimensional, it crushed all matter out of existence. There's no body there. There's no shape. Then what the hell do we have in front of us? Is it a geometric figure? Can we replace that nothingness with a point and say, with a dot, right? And call it a point. It's a point. Well, what is a point? Well, a point, is it the dot or is it the location? If it's just a location, so far we have nothing in there. You got to tell me what's in the location. And what they're saying is, what you have in the location is a location. That's what you have. And they can pinpoint it with coordinates, right? Whatever as they call them, number lines. And What's in there in that location? Absolutely nothing. All it has is runaway mass. What does that mean? Well, I don't care, because I need to have a physical object to show how that center of nothing influences a star that is gazillions of miles away. That's what we need to figure out. We need to figure out the mechanism. We don't care about their math. We don't care about their mass. What we want is a mechanism. For that, you need objects. And so far, we have no object in front of us, because they tell you in your face that matter has been crushed out of existence. What the hell are we talking about as far as a black hole, about this so-called entity, this so-called geometric figure represented by a point? We have nothing in front of us. And when they say, well, you know, you're not supposed to take the analogy literally, well, I haven't understood your mechanism. Sorry. You know, and it doesn't mean that I have to take a course in math, algebra, calculus, or whatever to understand what you're saying. You know, you should be able to tell me, like Einstein said, if you can't explain it to a barmaid, then you don't know it well enough. Okay. Okay, and so what's one of the biggest problem? And here you see it. Two concepts do not make an object. It's the other way around. Two objects make a concept. Concept is a relation between at least two objects. That's what a concept is. That's the definition of the word concept. A relation between two concepts, or a word that invokes at least two objects. You need two objects to come up with any concept, because a concept is a relation. But you cannot put two concepts and make an object. I cannot take intelligence and love, put them together and come up with a rock. And that's the big problem here. Here you have a location, which is the center of whatever. It's the center of the event horizon. What is the event horizon? It's the perimeter of the center. So it's like a circular definition. We have a point in the center, which is a location, and it's surrounded by a concept called the event horizon, which is what? A region of influence. So we have two concepts, and so far we have no object. And again, two concepts do not an object make. Conclusions. Here we go. This is what you can take home with you to the bank. Okay, you can put your hand in the fire for this. Geometry was misconceived from the start. Point, line, plane, all that stuff, misconceived. That's why they can't define it even to this day. They just tell you, we cannot define these terms. They're undefinable terms, or primitive terms, or whatever they say, you know. They cannot define these terms because you don't define objects. In physics, in science, you point to them. They should be able to point to a point to a line, point to a circle or any plane, and not have to define it. Now, plane is a category, but certainly line and point are not. Line and point are two-dimensional figures. One is a 2D circle, maybe a dot, right? And the other one is an extended rectangle, which is the so-called stick, called line. That's what we have objectively in front of us. Okay, anything more than that is in your tiny mind, not in mine. Okay, all I see in front of me is a stick, and the other one is a little dot, a circle. That's what we have objectively in front of us. I don't have to read more into it than what's in front of me. If I have to read more into it than what's in front of me, then we're not talking about a geometric figure. Now we're talking about a concept. Now you're asking me to make believe. You're asking me to be a mime and do juggling with balls that don't exist. That's what you're asking me to do. All figures of the irrational discipline known as geometry. Why is it irrational? Because it's has rotten foundations. Are locations and itineraries. There is not a single figure in all of geometry today that is not a bunch of locations, meaning itineraries. They are not sticks and stones. They are itineraries and locations. Okay, and geometry is the first attempt to merge math and physics into a religion known as mathematical physics. That's why you have irrational explanations today, because they started with rotten foundations. They carried them over into mathematical physics, and today we have this so-called religion, irrational discipline called mathematical physics, which attempts to merge math with physics when one has nothing to do with the other. You can do math over here. I mean, I did a lot of math in my life, but it's got nothing to do with a physical aspect, which is what people want to know out there, which is mechanisms. They want to know how Mother Nature does gravity, how Mother Nature does light, how Mother Nature does electricity. That's what people want to know. And then they're done with physics. They don't want to have anything more to do with physics once they understand why they get a shock when they put their fingers, in a socket. Mathematical physics is casually equated with science. That's the problem today. Mathematical physics is not science under any circumstance. We need rational explanations to do science. Irrational explanations, we had a lot of them with traditional religions. All we have now with math phys is just a new type of a religion. That's all it is. And the priests are known as mathematicians. We call them mathemagicians. And the black hole of mathematical physics is consistent with the irrational evolution of geometry. Remember, mathematical physics really starts around the time of Newton, maybe a little earlier, maybe 100 years earlier or so. That's when it really takes strength, and gets all this energy behind it. Until then, it was just more, everybody would study geometry and then, do measurements, calculations, all based on geometry. Then when you get into Newton's days, now you get more sophisticated algebra and geometry and calculus and so on. And now this thing takes off and people think that they're going to figure out the invisible entities that Mother Nature uses out there to do her stuff. They associate it with mathematical physics. They say, oh, we're going to figure this out through math, through equations, through measurement. And it turns out these are invisible, intangible entities. You're not going to figure them out with any equation. An equation has no power to give you any information about the nature of the physical entity that underlies all these mechanisms. Okay? And then, like all other figures, it is not a figure. Okay, they have no figures in geometry, and so black hole is not a figure. A black hole is a location that moves stars around and sucks their gases, and we have no idea how a black hole does it. Okay, let me get to the questions we had. People ask questions mainly regarding objects, things, some with regard to existence, but people are concerned about the word object. What do I say? I'll put this up front. The definition, the scientific definition of the word object destroys all religions. Okay, that's the bottom line, okay? And you'll see why. Okay, here's the first question regarding object. The fellow says, I have never seen or had any kind of contact with your wife. Yeah, okay. Thank you for telling me. At least I can eliminate one person from the 8 billion people on the planet, okay? Does that mean she doesn't have a 3D body moving around? Referring to the word object, body, thing, okay, figure. And here's the answer, okay? We can get this answer up here. What's the problem with what this gentleman is saying? Well, here it is. Now, it means that your definition of the word object, it has bombed out. You've got an irrational definition because you think that an object is that which you can see or touch. And you don't have to see her. You don't have to touch her. She's an object before you see or touch her. Okay? And each and every human qualifies as an object because any human has shape and not because you have seen or touched every single human. Is the Chinese on the other side of the planet not an object because you can't see or touch him? He disappears as an object? Do you have to see or touch him in order to for that Chinese man to become an object? Or the tree or the table that he has? Do you have to see and touch it? Until then, a table is not an object? No, hopefully the only property all objects have is shape. That is a universal property of objects, the only universal property of all objects. Okay? And so here are the list of words that you cannot use to define the word object. Remember, we have 8 billion people in this conference room. 8 billion people on the planet that are in this conference room. The doors are locked. We can't leave the conference room. We can't start doing physics until we define the word object. Why? Because the golden principle of physics is you can't do physics without an object. What would there be to move? What are you staring at? What would you do experiments with, assuming experiments were part of science. You know, what are you staring at? What are you watching? What phenomenon is happening without objects? So you need things, you need objects, you need bodies to do physics. And the question is, do we have to define the word object then? We need to know what an object is for the purposes of physics. And that's why the definition of the word object destroys all religions, because now you have to tell me whether your God is an object or a concept. Which one is he? Or it, or whatever. Which one is God? An object or a concept? Okay, so here are the words that you cannot use to define or that fail. So if you have any of these criteria, you can't use them to define the word object for the purposes of physics. You cannot use see or touch, primarily because you need a second object to do see and touch, and that means you have a circular definition. You need an object to define the word object. It's like you're using a synonym. And again, if you say, well, I can't see your wife, I can't touch your wife. Yeah, you can't see the guy on the other side of the universe either. And does that mean he doesn't exist? That means he's not an object. The table he has is not an object. So you cannot use the see touch criteria, which is what everyone uses out there. You can't see the air. Hopefully the air blew your house down. Hopefully it wasn't a ghost. Okay. Mass. Do all objects have mass? No, squares don't have mass. Neither do circles. Superman, you know, has shape, but he doesn't have mass. Okay? So all 2D figures don't have mass. And you say, oh, Bill, that's because you included 2D figures. Okay, how about the 3D table I'm thinking of? Does the word table refer to an object? Hopefully it does. But the one that's in, you know, the one that's out here that I can touch and see, that one you can see and touch, and that one has mass. How about the one I'm thinking of? Is that a table? You know, I can picture it, I can draw it for you, I can tell you which one I'm thinking of. And so I draw this thing that I'm thinking of. Neither the one I drew, neither the one that I have in my head has mass, or volume, or motion. Okay, so you can't use any of these words to define the word object for the purposes of physics. The only universal property, shape. It's got to be a standalone object, meaning it doesn't depend on something else. It can't be a dependent object such as the halo of an angel. Halo of an angel is either a plate or a ring without the angel. That's all we see in front of us. We see, objectively, all that we see is a ring or a plate. If you put the angel, you call it a halo. Why? Because it's a dependent object. You need the holy man or the holy angel, the guy with wings, for that to be called a halo. Otherwise, it's not a halo. Otherwise, it's just a plate, a ring, a cloud, whatever you want to call it. That is an object. But a halo is not an object. Halo is a concept because you need the object on which it depends. Same applies to the word field. Field is not a standalone object. You need the magnet. I can't bring a field to the conference room. In fact, every time you see the word field, you'll find some object related to it. There's this magnet or the electric terminal or something. They'll put something in there. You'll never see the field all by itself. No one draws a field all by itself because there is no physical standalone object called a field. It's a dependent object, meaning it's not an object, because if it's dependent, it's a concept. You need two objects to define the word concept. Okay? That's what a concept is, a word that requires two objects. That's what a field is. That's why you can't do physics with a concept called field or with a concept called wave. There's no such thing as a wave. Okay? And again, you can go through the list there. None of those qualifies as an object. The only one I'm going to mention again is exist. Exist and the word object are not synonyms, an error that both David Hume, and Immanuel Kant made. They couldn't determine what the difference was between the word object and exist. And that's because they were thinking of see and touch. And they say, well, you know, whatever is an object is what I can see and touch, and whatever exists I can see and touch, so they're synonym. I can't see any difference. Well, that's because they had the wrong definition. The definition is that which has shape. Some objects can be touched, some can be seen, and not all objects exist. Superman is an object that does not exist. A circle is an object that does not exist. So you can't touch it, you can't take it home with you because it's an object that does not exist. Physics only deals with objects that exist. That eliminates all two-dimensional objects, all two-dimensional figures. Word figure is a synonym of the word object. Okay, fellow says, along the same lines, says, if the Klingon showed up and launched the that coffee table towards you, would you understand it's an object? That refers to the fact that I said, well, you know, here's the Klingon on the other side of the universe. He's gazillions of light years away, whatever, right? He's very far away. You can't see him. You can't touch him. He has a table. Is that table an object? The fact that you can't see or touch it, does that, deny the fact that that thing is an object? Of course it's an object. The word table is an object anywhere in the universe. You don't have to see or touch it. Then why is it an object? It's an object because it has shape, not because you can see or touch it. Okay? And so here's the answer. Give me a second. I got to get them from the bottom here. Here's the answer. Would you understand that a table is an object even if the Klingon never showed up? Okay? Does a Klingon have to throw the table at you for it to become an object? That's the question you got to answer. I mean, do you prove that your table is an object by throwing it at your wife or whatever, your boyfriend? Okay, is that what you do? You say, let me show you that this is an object. I'm going to hit you with it. Bang you over the head with a table so that you know it's an object. No, hopefully you don't have to bang your partner with a table in order for the table to be an object. It was an object before you grabbed it with your hand. Okay, why? Because it has shape. That's the definition. Okay, again, another fellow, I think, here asks or says the following along the same lines. You have dismissed the issue of defining shape. This is a critical mistake. Ooh. Because, you know, an object is that which has shape. So he says, but you got to tell me what shape is. That's the issue. Okay? This is a critical mistake. By your own standards, even any model critical term must be defined. Absolutely not. We don't define every word in the dictionary to please the extreme devil's advocate. You don't have to keep defining. Guys say, okay, what did you mean by the? What did you mean by which? What did you mean by that? I mean, are those words any easier to define than the word shape? Can you define the word which? Can you define the word that? Do we have to define every word for you to understand what I just said? That which has shape? Has? How about has? You know, is has like I have 1 penny in my pocket the same thing as saying, oh, I have a headache? Are those two the same type of haves? Is it easier to define the verb have than it is to define the word shape? Of course not. And so what, you're going to just badger me forever and say, well, why don't you define this word? And what about this other word? And just going to go through the whole dictionary until I define every word in the dictionary? That's not what we do in science. In science, we have to compare the word shape against what the list that I just showed you. Against see, touch, motion, volume, mass. We have 8 billion people in this conference room. The doors are locked. We have to define the word object because you can't do physics without an object. And until we define the word object, we can't leave the room. We have to select a criterion, or if necessary, criteria, a couple, I don't know. But the issue is we have to define the word object before we leave the room. Otherwise, we can't do physics. We can't start doing physics. And so the issue is we have to compare or decide what criteria we're going to use. And for that, we have to compare all these possibilities. We have to compare shape against motion. We have to compare C against volume. We have to compare touch against exist, and so on down the line. And out of all those words, we got to choose one. And the only one that qualifies is the word shape, that which has shape. Now you're going to say, well, I don't know what shape is. Well, go to a kindergarten and, grab a ball, and grab a cube, same volume, same weight, same color, and just show the kids and say, what's different about these? And they all say, it's the shape. Then you'll know what shape is. You probably missed a class in kindergarten. That's your whole problem, okay? We don't define the word shape in science. We don't have to define the word shape. We need to know the difference between shape and see touch, which is the criteria that are being used today in mathematics, because they think they're going to go to the lab, see and touch, and through see and touch, determine what is the mediator of light, what is the mediator of gravity, what is the mediator of magnetism. That's what they're doing. They're using, by default or casually, they're using the word see touch, the notion of see and touch. Why? Because they want to do an experiment. Experiments are not part of science. In science, we have to explain experiments, not do them. Let someone else do the experiment. We just need to explain why, what caused that to happen. And for that, we need to identify the invisible entities, objects, things that Mother Nature uses to do her stuff every day. Okay, so a fellow says, shape, that which has a boundary between what it is, its body, and what it ain't, space or another object. Okay, keep that in mind. He's saying that which has a boundary, that's what he's going to define shape as. He wants to give a definition to the word shape. This excludes things like 1D lines, 0D points, infinite objects, platonically ideal fractals, etc. From the definition, readily includes 2D and 3D as edges and surfaces are boundaries. This is not only compatible with your usage of the term object, but also enhances it. Ooh, I think it takes away, but okay, let's find out. The boundary definition allows contact between objects. This, which is crucial for the thread's ability to twine into a rope without fusing into a rigid helix. Not to mention any other interaction that requires touch. Okay, let's find out. Here's the answer to this gentleman. Okay. And this is what the answer is. He's a dog chasing around his tail in circles. That's what he is. Because he says, an object that which has shape. He doesn't have a problem with that. He says we have to define the word shape. Okay, what is shape? He says shape is that which has a boundary between what is a body and what it ain't, a space or another object. So he's using the word body, which is the word object. That's what a word body means. Or he says another object. Again, he's using the word object. What is a boundary? Well, a boundary where an object ends. In other words, an object, he needs the word object to define the word boundary. So all this guy did was chase his tail around, but he's not smart enough to figure it out. He's got object, that which has shape. Shape, that which has boundary. Boundary, that which requires an object, or that where the object ends, so we're back to object. All he did was chase his tail around. So he doesn't understand this, that these people think that this is simple, that they can just go in there and do whatever they want. And no, they have problems with their logic. They're irrational individuals. They don't understand that you can't use synonyms or go around in circles with definitions. You have to define all these words in terms of words that are not synonyms. That which has shape, shape is not an object. Shape is a property of an object, an attribute of an object. Shape itself is not a synonym of object, even though we sometimes informally say, shape, like we treat it as an object, a synonym. But formally, it's not. Shape is a property. It's like an adjective. It qualifies what an object is. Okay, it's like an adjective. It's a quality, property, an attribute, whatever you want to call it. Okay, and here's just like the icing on the cake, because not only this fellow was irrational. Here we have Mr. Euclid and all the Greeks that gave him this so-called knowledge. Okay, and what did Euclid say? Let me put it over here. And he ran into trouble because he says, definition 13, this is in book 1. A boundary is that which is an extremity of anything. Well, good old Euclid did not understand that anything means figure. That's what anything means. And so now he defines 14. He says anything, in other words, a figure, is that which is contained by any boundary or boundaries. All he did was revert back to 13. So he's going back and forth. He's chasing his tail around. He's saying a boundary has something to do with things. And what is a figure? It has to do something with boundaries. So all that Euclid did was run around in circles. He did not understand this. And again, people get stuck in these chasing their tails around because they don't pay attention to these little tiny details which have made a significant difference. These words are very crucial to define if you're going to start the discipline known as physics. These people never understood it. They thought that they could go in there and just define these words very casually, very informally, and say, okay, this is good enough. No, it ain't. It ain't good enough. You need to be a lot more careful with your definitions. Okay, definitions are crucial because they form the foundations of physics. Okay, that's why they're crucial. You got to define these words properly. Okay, another person asks, similar, they're all along the same line. Well, because I was covering the Mandelbrot shapes the other day, okay, which is that one there on the bottom left. That's a Mandelbrot set, okay, it's called. So the Mandelbrot set is a shape because it doesn't move. Correct. So far, so good. We do a fractal zoom, and now they aren't shapes because of motion. Correct. The word shape is a static concept. Okay, like standing is a static concept. Moving is a dynamic concept. But standing is a static concept. Okay, you're not doing any motion. It's a relation with respect to something else. So we're saying the tree is standing or the rock is standing. It's not doing anything. So standing is a static concept, like direction is a static concept. You're not moving anything. You can move along a direction, but the word direction itself requires two objects first, and second, it's a static concept. There's nothing moving that you need to have moved within the word direction. All you have is just like an orientation, a pointing, a facing between two objects. That's all you have with the word direction. And so what's the issue here? The issue is that, a Mandelbrot set, if it's a static thing like you see on the left, that is a shape. Nothing's moving. It's a static concept so far. So far, we're okay. Now, look at the one on the right. Well, I don't know. Is that a shape? Oh, it just moved. Sorry. I can't tell you because it keeps moving. So that's not a shape. That's not an object that I'm staring at. I'm staring at a movie. But what's the issue? The issue is I can take a cross section of that. In other words, one frame, freeze that. That one has shape. Hopefully, each frame of the film in that movie has shape. I have to make it stand still. Now it is a shape. It has shape, whatever is in that frame. But I can't say that something that is moving like this constantly, that's a movie. That's a movie with gazillions of shapes. That's not a shape. That's a movie of many shapes. And again, that's not a shape. That does not qualify as shape. Shape is a static concept. Okay. So yeah, because they're in motion, they're not a static. They're not shapes. They're not a static concept. I paused the video. Did it magically become a shape? Not the video, but one of the frames of the video has shapes in it. In other words, the objects in there all have shapes. Okay, very simple. Is it now an object because it has shape? No, the object has shape that's inside the frame of the movie. You stop the movie, but you're not looking at the whole movie. You're looking at just one frame in the movie. Whatever's in that frame had better have shape. Otherwise, you're staring at a blank frame. That's it. Did one jump off the screen and hit you in the head that hard? No, you don't have to have objects hit you. We don't rely on touch to define the word, or see for that matter, to define what an object is. No, an object is that which has shape all on its own before it hits you. Okay, the baseball bat is an object before it hits you. Okay, hopefully I don't have to use it. Okay, so yeah, shape is a static concept. Okay, let's go with the next question or comment. Well, it says, absolutely no one has and no one ever will possess a two-dimensional object. There is nothing as such. Go outside today and wonder about your shadow, because a shadow is not an object and a shadow does not have shape. Not in physics. In ordinary speech, shadows, people say, oh yeah, the shape of the shadow. Not in physics. You cannot say that in physics. Okay? Not in physics. Why? Let me tell you why you can't say that in physics. It is irrational to say that a shadow has shape. Shadow has shape. Tongue twister there, okay? Okay, here it is. First of all, guy says no thing. That's what nothing means. No thing. And yeah, we do have a thing. Thing is that which has shape. So the two-dimensional object hopefully has shape. That part we have. You don't have to possess it because an object is not that which you possess, meaning that you can touch. That's not the definition of the word object. An object is that which has shape, not that which you can possess. You don't possess the table that the Klingon has 2 gazillions of miles away. Okay? You don't possess that table. So touching, seeing, possessing, none of those are definitions of the word thing. A thing is that which has shape. A circle is an object for the purposes of science. Why? Because it has shape. We have no purpose for inexistent 2D objects such as circles in physics. Physics deals only with 3D objects. Now, shadow. Why is a shadow not an object? Because the word shadow means blocked light. There is no physical standalone object called block light. Okay? Now, if you see that there is a physical object called block light, please bring it to the conference and we'll find out if a shadow, this block light, has shape. Okay? Block light is not a shape because it's got to be a standalone object. Okay? And the shadow is not a standalone anything. Shadow is a concept, and concepts do not have shape. Okay? No standalone objects such as block light. Okay? I hope that's clear to a rational human being. It is not to religious people who see their religion suddenly die because the word object destroys all religions. Okay? Fellow says, here it is, says, have you tried to tell a surfer, have you tried to tell a surfer that a wave isn't a physical object? It's just a verb, right? No waves today, Johnny, they are verbs. Okay, so what's the problem here? Let's see if a rational person can figure this out. Okay, here it is. Says, here it is, the answer. It says, exactly, what a surfer is surfing on is known as water in physics, not waves. No such thing as waves. And there you see, is that a wave? No, that's a flag, not a wave. Wave is what the flag is doing. The object is flag. Hopefully you won't confuse the noun flag with the verb wave. And that's the same thing on the left. On the left, what you have is a surfer, and he's on water, not on a wave. Okay? The fact that we informally call it a wave, whatever the water is doing, that should not be confused with the noun. But that's what people do. They bring all these words of ordinary speech, these notions, they bring them into physics and they say, oh, the wave. You can't do that in physics. You got to bring the object, not what it's doing and calling it a noun. That's where the problem is. And there you have the famous saying, the definition of the word object destroys all religions. Okay? So here's the punchline on that. Let's see if people can understand what I'm saying here. Okay. Is the God you pray to an object or a concept? Okay. Does your God have shape or not? I mean, I don't care if you believe in the God of the Christian Bible or for that matter, the Quran or whatever. I don't care if you believe in space-time. Is that what you pray to? You pray to the black hole, to the planetary atom, to energy, that mystical stuff that floats everywhere, nobody knows what it is, to the wave. I don't care what your God is. You got to tell me if your God is an object or a concept. And I brought that issue up with some folks, Palestinians who were in Aberdeen, Scotland, a few years back, I think 2010. I went to Scotland to a conference, and I asked them. We went to lunch with them, nice fellas, and so they were Muslims. And so I asked them. I said, "Okay, is your God an object or a concept? Does your God have shape or doesn't he?" And that stumped them because I got different answers. One guy said, well, if I knew what God is, then he wouldn't be so great. That's the type of answer one guy gave me. Another guy said, well, he's both. Oh, he's both. He has shape and doesn't have shape simultaneously. And he said, well, he can be one or the other. He can turn from shape to no shape. No, that's not the question. The question is, at any point in time, does he have shape or not shape? And yeah, that's where they start thinking they never ask that question to themselves. And they have no answer for that because it's a black or white issue. It's either black or white. It's on or off. It's yes or no. You can't say, oh, it has shape, but it doesn't, or, I don't know, and I'll find out. You can't answer like that. It's just a straightforward question. Does your God have shape or not? Who do you pray to? Do you pray to space-time? Does space-time have shape or not? That's the issue. And that's why the word object destroys all religion. It compels the believer in this nonsense to tell you, right? Whether their God, the one they pray to, the one they believe in, has shape or not. And of course, they're going to weasel out of that one. They're going to do everything in their power for you not to destroy their religion, because that sentence there destroys their religion, that comment. The definition of the word object, the scientific definition of the word object, destroys all religions. Whoever God you believe in, you got to tell me whether he's an object or a concept. And if you believe that your concept was an object, which is typically the case, and you treat them like an object when it's really an abstract concept, black hole, for example, then you got a serious problem. Because now you realize what physics is all about. What is physics about? Objects. First and foremost, you need an object. You can't bring in a concept, love, and treat it like an object. Say, oh, I'm going to move the heart around. Now, if you're going to move the heart, decide whether you're going to be moving the heart or the love. If you're going to move love around, you got a problem, because love is a concept. You can't move love. If you're going to move a heart, don't call it love. Period. We're done. Okay. One fellow says, scientists. They call them scientists. They're not scientists. They're just a bunch of nobodies that have a PhD, and they call themselves scientists because everybody believes that a scientist is someone who has a PhD. Even though all the guy did was warm a seat in college during 10 years, they're called scientists or physicists or mathematical physicists or whatever. No, they're not scientists. A scientist is a guy who thinks, who rationalizes, who can explain. That's a scientist. But a guy who does nonsense at the lab and cannot explain anything, that's not a scientist. Scientists at the Lund University Faculty of Engineering in Sweden have managed to capture the electron motion for the first time. And this is the nonsense that these so-called scientists come up with. They show you that and they say, oh, look, I'm a scientist. I filmed the electron. Well, I don't care if you filmed it or you described it mathematically. That's not a scientist. A scientist is a guy who explained. So what is it that a scientist has to explain? Well, how about if they explain this? Now we have the movie, great. Okay, now explain this. Explain, if you can, what an atom looks like. I mean, if your blue ball looks like that blue ball going around, right? Because that's what they claim that they filmed. Okay, so we got that blue ball going around. What we need for you to tell us is what your atom looks like. According to Niels Bohr, the atoms that's still used today is that electron jumps between energy levels, okay, around a nucleus or proton in the case of the hydrogen atom. Great. I need to know what the white stuff is within the two circles. What is the white stuff that compels the electron bead not to remain faithful to the proton and not fly away spontaneously? That's what you need to answer. If you cannot answer that question, you're kicked out of the conference room. You're not allowed to give your presentation, your dissertation, because you don't have an atom. So you got to start by justifying your atom. And right now they can't justify their atom. So I don't care if they film the electron, they cannot put that electron in an atom and show us the atom. That's the problem. So it shows you that doing experiments and filming this nonsense that these people film there give us no idea whatsoever of what science is about. Science is about explaining something. And right now what they cannot explain with that little electron that they filmed, supposedly filmed, is that they cannot tell us what their atom looks like. We need to know what their atom looks like, and that's a conceptual issue. It has nothing to do with running experiments in the lab. Now, and there's another problem. You can see that electron bead on the lower left, the blue one there that these people, the scientists, so-called scientists, filmed. It has shape, it has some diameter, it has some size. And to this day, the official version from quantum mechanics is that the electron is a point particle. It has no shape, it has no size, it has no radius. How can these people film what officialdom says has no shape, no size, no diameter, no radius, no nothing, no volume? So what did they film? What is this nonsense? So they take a picture or a film of something, they bring and say, oh, we filmed the electron, give us our Nobel. Absolute nonsense. It shows, how ridiculous so-called science, mathematical physics has become. That's what it shows. That's evidence of. Okay, question along the thread, the rope model. Here we have them. Bill Gates cannot use the word shape without evoking geometry. I don't know why, because math has nothing to do with shape. Geometry, what he calls geometry, is numbers, relations, equations, measurement. That's got nothing to do with physics, which has to do with shape. So yeah, we don't need geometry. Not the geometry that the mathematicians do, which are objectless. There are no objects in so-called geometry. So yeah, it's the other way around. We can use the word shape because we're going to do physics. Geometry, the mathematicians, they cannot use the word shape because they have no use for the word shape or for objects. They don't deal with objects. They deal with itineraries, measurement. What is an itinerary? What they're doing is unrolling the measuring tape. That's what it is. So they measure and they say, oh, we measured. What did you measure? You measured how a location went from location A to location B. That's what they did. They just measured locations and the motion of locations or a series of locations. And what they're conceptually doing is unrolling the measuring tape. That's all it is. So they're looking at the starting point of the tape and the ending point of the tape. They measure that. They say 1 meter, and that's what they use. They use the 1 meter. They have no use for the actual physical object that measures 1 meter. Okay, so hopefully that's clear. Math is a language, he says it. True. Even rational science is in. Absolutely not. We have no use for math whatsoever. And if he doesn't use it, he can't explain anything at all. Math is a language that does not explain and cannot explain. Mathematics can only describe, has no power, no authority, granted to it to explain anything. You cannot explain anything with math. You can only describe. And if you haven't learned that, you know nothing about math. An equation is a description, explains absolutely nothing. Explain, you have to use a different type of language. You can use Chinese, you can use Greek. I know it's Greek to you, but you can use those languages, but you cannot use math to explain. Math can only describe. If you haven't learned that, again, you don't know nothing about math. Bill Gates' thread is an infinite object. Where did he get that? My God, what do these people have in their minds? Therefore, we can't use your definition of object in rational science, and any definition of object will have to allow for the use of 1D lines and 0D points because of how many dimensions the thread has. The thread has 3 dimensions. What part don't you understand? It's 3D. It has length, width, and height. Yes, every object can be represented as an itinerary in the thread. No, we don't represent a dog with an itinerary. You got to put the dog, sorry. There is no substitute that you can put, especially in motion. You can't put a verb to represent a dog. You got to put the dog, But here's the issue. He talks about my thread. Here's the thread, Here you have 2 threads. Each one forms a different universe. Those threads turn into every atom in each universe. And you can see that the thread first has shape. And then one thread has distance with respect to another. That means that they both exist because they meet the condition of the word exist. They have distance, in other words, location with respect to each other. We have the word exist. So we have the thread and we have existence. We have no, we have the thread is an object, and we have the object that exists. We have no problem here because we can define the word object. It has shape, and we can define the word exist because one has location with respect to the other. Period. We're done. Okay, that's how simple it was. Let's move on to the next question because we're going to return to that one. And here, fella says, so it's not infinite, by the way. Each one of those is a closed loop thread, so it's not infinite. Infinite is you going around the thread. That's not infinite. It's called incessant running. Do not confuse the word incessant, which is what the idiots of math do, with the word infinite. Infinite is an adjective, can only be applied to objects. There is no such thing as an infinite object because it's an oxymoron, a self-contradiction. All objects are finite. Therefore, the word infinite is an irrational term to introduce into physics, into science. You can use it in ordinary speech, not in physics, not in science. And the thread is not an infinite object. It's a closed loop, finite object that does not stretch, which is the next issue here. But you can run around it forever. If that's what you call infinite, you don't know what the word infinite means. It's incessant running. Incessant running is not infinite. Okay, and this fellow says, how stretching or bending happen in single piece thread? Oh my God. The thread doesn't stretch. It doesn't stretch. It's made of a single piece. It doesn't stretch. Okay, so there's only so much matter in the universe, and that's the amount of thread. You could say the closed loop thread has only a certain length. If we could stretch it completely out, undo all the atoms, and just stretch out, all we would have is a single thread in the universe that makes up all matter. It doesn't stretch. It's made of a single piece. We're done. Matter does not create itself because there's only so much matter in our universe, unless there's another parallel universe, another parallel thread, in which case we have two universes, a parallel universe. None of the atoms of that universe are connected to any of the atoms of our universe. We cannot see that universe. We cannot touch it. Well, touch it probably, but we cannot see it. Why we cannot see it? Because in order to see, you have to have the rope come into your eye, and none of the ropes of that universe are connected to the ropes of to the atoms of your eye or to our universe. Okay? Now, we can still collide. We can't see, but we can collide because atoms can still collide, surface against surface, if they happen to, the two universes happen to cross through each other. And that's the only time you can see, you can experience an atom coming through your wall and maybe hitting you or whatever, or out there in the field. Again, that's a speculation. I don't think two universes can collide. They're probably not even close together if there is another universe, parallel universe out there. Okay, so what is our universe like? What is the thread like? Okay, well here, let me show you. Okay, let's see if I can show you this. Give me a second here. It says, how can you bend it? How does a thread bend? Well, I'm going to do an experiment for you, okay? Very important experiment. You like experiments? I'll do an experiment in front of you, and this is very expensive, very unusual experiment, okay? I'm going to bend the thread for you. I'm going to show you how it bends. Okay, here's the thread, okay? Watch it carefully. And there, I bent the thread, okay? See how hard that was? That's how it bends. Now you know how a thread bends. That's a thread, and there it's bending. And I did it several times. I hope you caught that. Okay, you can watch the movie later on. You'll find out that I did actually bend the thread. So that's how it bends. I mean, I don't know what question you want answered. That's how you bend a thread. We're done. Okay, that's how a thread bends. Okay, let's move on to a more rational question. Here, a person asks, I think it's more rational, we'll find out. The rope is under tension everywhere, yeah, and the rope is fluid, yeah. Okay, what Getty has a surreal, self-contradictory object that fails his own criterion of existence, to have location with respect to another object. Well, again, I showed you here. Okay, there you have it. So there is no contradiction. There you have two threads. One has distance, location with respect to the other. So both of those threads exist. So we're done, I guess. That's it. There's no more than that. Okay, so we do have existence. We have an object and existence, both, because we have location. That's the definition of existence, object with location. Any rational thinker can come to the conclusion that all fundamental, non-composite objects are fully solid and do not deform in any way in our everyday world. In fact, we don't have such an object in our everyday world. Even a steel beam is made out of atoms, and it has space in between, the atoms. That's what gives shape or provides shape or contrast to each atom. So there is no such thing as something made of a single piece in our everyday world. Now, you have steel beam, which we say, well, it's quite rigid. Yeah, it is quite rigid. But the issue here is you cannot extrapolate to Mother Nature's world all the properties that we have in our everyday macro world. Not all of them, not all the properties or attributes are transferable to Mother Nature's world. Obviously, Mother Nature runs a different kind of world than we do in our everyday world, the see and touch world, because her mediators are invisible and intangible. So you got to explain invisibility and intangibility. You got to make an assumption about what she could be using there, because otherwise you're replacing that with spirits. So she is using some kind of object that we cannot see or touch, and none of that can be imitated by anything we have in our everyday world. You cannot go to the lab and imitate her world, her invisible, intangible world. Whatever you do is going to be seeable and touchable if you're going to the lab. Experiment can only deal with seeable and touchable, with visibility and touchability, tangibility. Experiments do not deal with the invisible. To elucidate the mediator, you will not be able to deal with see and touch, because Mother Nature doesn't use see and touch, our see and touch, to run her world. So you got to make some new assumptions, and among them is that this notion that if it's made out of a single piece, it's rigid. No, Mother Nature's world is in reverse. It's made out of a single piece, and it is not rigid. It is a malleable, single piece entity that she uses, just like it's invisible, just like it's intangible. Okay? Why is it intangible? Okay, because seeable is a little easier to explain probably. I put this up, let me put it one more time. We have the sliding hand. Okay, let's make sure we understand the concept, why it's untouchable, why it's intangible. Here it is. You have 5 fingers, and we're pulling one atom just at random from each finger. The hand is moving towards the ball. Okay? What the atoms are doing is sliding through the ropes. Why? Because the rope is made out of 2 strands, and the atom is somewhere in the middle. Here, let me put it here. Okay? And so the rope itself, each one of these threads, make up the atom. Imagine you had the abacus in front of you, okay? And you have these beads that you can slide. That's more or less what I'm showing there. So you have these beads, they slide, but it turns out that the beads are made of the same wire that it's sliding through. So the wire, one wire goes above, the other one goes through the center, and the bead is just sliding through this wire that makes up the bead. The bead does not really touch the wire because it is made of the wire. You can say it touches it at all times. The bead can touch another bead, can bang against another bead, but it cannot bang against the wire of which it is made and through which it's sliding. And that's what I'm showing here. You're seeing the atoms, they're sliding through the ropes. Those are ropes, okay? And the ropes make up the atom. So you can't touch the rope itself. You can only touch another atom. You can't touch the rope of which the atom is made. That's why you cannot touch these atoms, okay? And I don't know if that sank. What we're talking about is atoms sliding through the ropes, okay? And there was another issue he raised here. Let me put that back in here. Okay, he says the rope It's under, okay, any rational thinker, okay, got that. I investigated ideas where the rope is made of inconceivably tiny but absolutely rigid chain links. He thinks he's going to do this with a chain. He's going to talk about, links being the chain. So he's going to say that the so-called rope, he's going to put a chain in there, and he's going to put links one right after another in series. Okay, so again, the notion of a chain. A chain of fundamental objects is permanently intact by definition, but is allowed to deform simply by reorientation of the rigid links, just as in real macro-scale metal chain. What this guy is proposing is quantum mechanics, particles. He's proposing that the particles look like links, okay? And so he wants to fix one problem, but he opens up a can of worms in another sense, and he doesn't realize that because he doesn't have the mental capacity to understand what he's doing, okay? What he's doing, he's saying, I'm going to replace the rope because I don't like the rope because the rope is made out of a single piece, and then we can't go through it. We have this problem of ropes crossing, etc., threads hitting each other and so on. So he said, no, I'm going to replace the rope and I'm just going to put a bunch of links and make a chain. Well, now he created a bigger monster. He's got more questions to answer than the rope. And here are the questions he's got to answer. So let's put this up there so we can have something graphic. Okay. Here's the chain. Okay, so here we have a chain. Okay. And what this guy is saying, that we have all these links, we'll call them links, okay? Chain links. And so if we can move the chain now, because now he says, see, now we can see why it's malleable. Great. Okay, we fixed the malleability problem. So he alluded the thread made of a single piece which is malleable. That's the one he's going to address here. So he says, see, if we put links there, we solve the problem of malleability. Okay, now that chain breaks. Okay, because it's got to break because we're going to have chain going through chain. Okay, that's the first issue. And here the problem is that if it breaks, how does that link go back and become part of a chain again? How do these invisible or loose links combine again to make a chain? And then we have the problem is, what does your proton look like? Which is a bigger problem. I mean, with the threads, no problem. We have a thread going to the center of the atom. We have the star in the center of the atom, which is, pointing in different directions. I think I have a picture here. Okay, let me show you this so you see what I'm talking about. Okay, here it is. Okay, so you can see the atom. It's made out of those, I've got it moving fast, but you can see what I'm talking about here. The proton is made of threads. One thread goes around, forms the electron shell or membrane that encapsulates the star in the center. The center is made of all the threads. We call them electric threads arbitrarily to keep with convention. And those threads come from every atom in the universe. So we have an explanation for the proton. How do you explain this with these chains that he put up here? Let me put that back up here. How do you explain it with that? How do you explain the proton with these chains? What is this ridiculous notion of chains making up the proton? That's what he's got to explain. Okay? And so, yeah, you can't elude that question. And I think I have one more issue there. Let me see if I get it here at the bottom. Yeah, what he's proposing essentially is what string theory proposes, and it looks more or less like this. Not exactly, but he's saying, look, and those rings are malleable in string theory. Think of them as solids, as undeformable. You can't deform these like you see them here. They're made of a single piece, okay, and they're links. And so you have all these little links going around. How do they combine and form these chains? That's what he's going to answer. And so this is the ball is in his court. He's got more to answer than what we find with a rope model. And with that, I'll see you next time on, on Sunday. You don't even know what date, what is it, 23, I think it is. We'll see you then, Sunday, next week, end of the week. Bye-bye, and have a good weekend.